once again. You're welcome to our channel, Physics Calculation Center. You remember the last time we saw power and energy, but today we want to put these concepts into calculations. You know, physics is about calculation. Let's put all the concepts that we have learned in the second video into calculations. Now, let's see this example. A boy dragged a bag of rice along a smooth horizontal floor. Okay, with a force of 2 Newton, with a force of 2 Newton. Okay, applied at an angle of 60 degrees. At an angle of 60 degrees to the floor. Okay, the work done to the floor. The work done after a distance of 3 meters. After a distance of 3 meters. The question is a past question, a JAM past question. JAM 2007. Okay. Now, since the movement, if you remember from our videos past, the one we did, that we said if the force is applied on the horizontal, the formula is different from when it is applied on the vertical. Now it says a boy dragged a bag of rice along a smooth. Okay, so that means the boy was dragging it along a smooth. He was dragging it. Okay, so the boy was dragging the bag of rice. So this is the object. So let's put the object here. Bag of rice. So he was dragging it. And he was dragging with a force of 2 Newton at a distance of 3 meters. Okay. Now, remember when this work done on the horizontal is F cos theta times the distance times distance. Now, theta here in this case, in this question, is 60 degrees. 60 degrees. So you come here and say 2 times cos 60 times the distance covered, which is 3 meters. Okay. When you use your calculator, cos 60 will give you 0.5. Cos 60 gives you 0.5 from your calculator or from your 4-figure table. It gives you 0.5. When you multiply this together, it gives you 3 joules. So this is the work done by the boy because he was dragging it on the horizontal. Now, you see, I didn't say, yes, the conventional formula for work is work equals force times distance. But I have told you, now work can be done in a particular direction. Anytime you are given a question that work is done on the horizontal, this is the formula you use, F cos theta times distance. Okay, good. Let's take one question before we close the video. Now it says, a constant force of 40 Newton, a constant force, example 2, a constant force of 40 Newton acting on a body, initially at rest, gives an acceleration of 0.1 meter per second squared for 4 seconds. Calculate the work done. Calculate the work done. Calculate the work done by the force. This is also a past question. It's a past question. It's JAMB 1987, I should think. Yes, JAMB 1987. It's a past question. I told you on our channel we'll be seeing past and present questions. Okay. So let's shoot. Solution. The first is 40 Newton. You have acceleration at 0.1 meter per second square. What else we have? We have time to be 4 seconds. Okay. And we need to calculate what? We need to calculate the work done. And we know work is force times distance. And we don't need distance. We don't have distance. We know work is force times distance. So we need to find distance. So we need to, since it has to do with movement, we can use the equation of motion. So you can use S equals ut plus half at squared. Okay. Since it is at rest, it means initial velocity is 0. Okay. It means initial velocity is 0. So this is 0. So distance here will be 0 times t plus half times 0.1 times time, which is 4 seconds. 4 raised to the power 2. Okay. If you do that, it will give you distance to be 0.8 meters. Okay, since I now have distance, I can now calculate work, which is force times distance. So work, force, which is, where's our force? Our force is 40 Newton. 40 times distance that I got 0.8. So work will be 0.8. So the work there will be what? 32 joules. 32 joules. Okay, beautiful. So you can see I've been able to employ the formula of a work on the horizontal and a work moving, a bag of rice moving. Now, listen to me. Your parameters helps you in physics. From these parameters, I knew what to do. I have force, I have acceleration, I have time. And they said it was at rest, so I knew initial velocity is 0. Now, but there's no distance. But I know work is force times distance. So the first thing I need to do is to go look for distance, to find distance. So I use this, you just check it. This is better. Distance equals ut plus half at squared. So this is 0, this is 16, divide it, multiply it by the 1.6, it gives you 0.8. 0.8 times 40 gives you 32 joule. And I hope you understand this. Now next video, we will try to do more calculations on power and energy. And before then, I would want us to practice on our own, and I believe you are going to get better. I'll see you next time. Bye.